Good day to the jury members. This is about the project presentation for Yukti 2.0 with the submission ID 152 entitled Development of Common Salt-Based Biosensors for Detecting Bacterial Viability from Ratnam College of Arts and Science, Coimbatore, Tamil Nadu. We have submitted this video under Yukti 2.0 initiative of Ministry of Education, Innovation Cell and AACTE. To introduce the team members, we have Dr. Sabrish KPN, Dean, Research and Development of our institution, who would be leading the team. Dr. Kalaivani T, Associate Professor, Department of Physics. Dr. Srinivasan P, Head, Department of Microbiology. Dr. M. Radhalakshmi, Assistant Professor in Microbiology, would be the team members. And Dr. Suresh SN, Dean, School of Science, would be our mentor. The problem statement, to start with the problem statement, microorganisms are ubiquitous in nature, surviving in almost all varieties of environments. And there is a group of microorganisms that belong to viable but non-culturable state. These microorganisms have adopted different strategies to survive in the environmental condition. For basic and advanced research, it becomes imperative to identify the viability of these microorganisms using one or more techniques to enable the success of the research process. There are many methods that exist to identify the viability of the microorganisms, but they are time consuming, expensive, and requires a multitude of sequential steps to detect the bacterial viability. To solve this problem, we identified a proposed solution, namely the biomineralization by microbes. Biomineralization is a natural process which is happening either directly or indirectly by the microbes as an active or a passive process wherein the salt that is present around the environment, around the microorganism, would be metabolized and would be precipitated in one way or the another with the help of the secondary metabolites. So, with this component in hand, we are trying to develop a salt biomarker as one of the biosensor to identify the viability of the microorganism. To test this, we utilized the common salt, which is the table salt sodium chloride solution as a solution form, and observed the crystallization form of that sodium chloride under the laboratory condition. And we observed that the crystallization varied according in the presence and the absence of the microorganism according to the various conditions that are set. Right now, we have filed an IPR patent on this concept, and also we are optimizing the methodology to detect the variable crystallization nature of this salt under various conditions and for various different kinds of microbial species. So once this methodology is optimized, this could be used to create a prototype biosensor that which would in turn be utilized for identifying the viability of the microorganism in a real-time environment, especially in the water environment, especially in the drinking water system. So, coming on to the business potential, the biosensor market, as we all know, as per the information taken from the current internet source, it would grow for a 7.5 percentage from the year 2021 to 2026. So we have a good business market for biosensor, and our concept, when it is created into a prototype and then when it is created into a final product, it would be simple to use and it would be user friendly, and at the same time it would be eco friendly in nature, cost effective, and could be applicable for most of the basic research that employs the detection of microorganism and its viability in the tested sample, especially in the liquid samples. And we are confident that our product could penetrate the local and global market substantially, because this is a basic research material which is in the need for the hour for almost all sort of research in case of life science need. And there are possibilities for opening different research and development in this area, in this particular biosensor product, so that it could be developed into an advanced mechanism as well. So to elucidate the proposed innovation, we have not yet created the prototype, but we are ready with the certain videos to explain our principles. The first video elicits the natural evaporation of the liquid under the time lapse video. As you can see, the water droplet is getting evaporated, leading to the formation of residual crystals. In the second video, you could see the natural evaporation of the saline solution, and at the end of the evaporation you could see the presence of cuboidal crystals of sodium chloride, which which is the natural mode of crystallization of the salt. But at the same time, if you refer the final video, this is in the natural evaporation of the saline solution in the presence of the microorganism. This happens to be in a state of a variable form where the salt, sodium chloride, instead of getting naturally crystallized into the cuboidal form as in the previous video, now it is getting crystallized in the form of a dendritic form. So these dendrites are being crystallized or being formed only in the presence of the microorganisms, and the nature of the crystallization, the time of the crystallization, the length or the degree of the crystals formed vary from microorganisms to microorganism, and also vary with the laboratory conditions which we are elucidating right now. So based on these principles, we propose to generate a prototype for the salt biomarkers, which could be a basic research component in every researcher's toolkit. We thank AACTE and the Innovation Cell for providing the opportunity to present our project for Yukti 2.0. Thank you all.